like Coded hands-on hacking session on Wiki, and today we'll talk about the Coded indexers and how to make queries in the GraphQL. So first of all, why do we need the indexers? We basically do not want to sacrifice the user experience. So basically, you can read all the data you have from the blockchain directly. But if you, for example, have chance to try, for example, Polka.js apps like .apps, it takes a lot of time, for example, for you to load all the data about staking, and this data doesn't change often. So it would be really nice to like have the first and fast load for the user, and you don't need to sacrifice UX. So user does not need to wait like a lot of time to see some data. Next point is like analytics. So making also processing the data in general on front end, is it considered as a bad practice. So if you want to see some views, it's better and faster to do it on the backend side or just on directly on the database and use front end just to show the data. Third point is like you can process remark, because basically the current implementation of remark is just a basically string into the blockchain. So imagine you have a string which starts with the RMRK, and you have some rules how how to parse it. And the fourth thing is we have like the simple GraphQL interface. So instead of using the REST API, as you may know, we have like simple interface and you query basically what you need. What's what's the indexer in general is like the tool or the script which is processing the blocks from the substrate one by one. And we have the two types of data in the blockchain. First is event, and the second one is extrinsic. So extrinsic basically is the call or the transaction that the user makes to the chain. So for example, if you open Subscan, yeah, this is my account, and when you go to the like extrinsics, you see that I made some actions. For example, here is like the balances as is transfer keep alive, so I send someone some kusama. Then we have the second data type, which is called events, and it's the interaction that are emitted by the chain. Basically, you can, for example, await for some transactions, so you can just listen to some events which were emitted by the chain itself. For example, if you transfer some token from one account to another, the chain emits the event called balances.transfer. And rule of thumb basically is to, or more effective, is to process these events, because is opposed to extrinsics, the events are final. So when you have like specific calls, for example, proxy calls or some pseudo calls, it can it sort of change the behavior of the extrinsic itself. So the better is to like process the event. And how does the processing work? So for each block, it will extract all the requested extrinsics or events. So if I want to just process the system.remark, I'm interested in this. So it will extract the each system.remark extrinsics from each block. And for these extrinsics, we call the predefined handler. And handler is sort of the function which takes the parameter like what was inside the call or query. And then handler transform this data to match the schema we defined in the database. And the last thing is we save it, basically. So which indexers do we use? We use two types. First is subquery, or we call it like magic. And the second one is subscript. We call it Rubik for the remark. And first we use the subquery since like last year, and it's the simpler one with less features. Since we use it like for a longer period, it like has less features. It also has like slower indexing time, so to index subquery would take like 4 days to process all the like 9 million blocks. And yeah, it's the backbone of the code.remark marketplace. So every query which you write basically for remark is with a subquery. And so far we use it because it's stable, and it has unfortunately no ability to make it external calls. So for example, can't fetch the metadata from the IPFS. Also, the other features are like the aggregations out of the box. So if you want basic analytics about the collection or about the NFTs, it's simple out of the box. So I don't need to write any specific resolvers or any functions. And last thing is that you have auto balance for more nodes. So imagine that all these indexers are decentralized and your queries are auto balanced through the world. So we have one endpoint and it's auto balanced behind. The second one is Subsquid, which is a bit more complex, but it offers higher flexibility. Also, it's super fast. So we have the version 5 currently, also using the version 4, and it can be used for the external calls. So in Subsquid, I, for example, save the metadata for each NFT. But on the other side is like the alpha quality software. It means that like it comes with the bug, with a lot of bugs, but fortunately the team is your base, so anytime I found the bug they can fix it like within the couple of hours, so it's like super fast. They are super nice. And the biggest thing is that we can write the custom queries, or called resolvers. So it means that on the top of the database I can write the raw query with SQL for the Postgres, and then call it through the resolver. And yeah, how does the schema look like? So basically there are two main entities for each, like also both for the subscript and subquery. First is the collection entity and has some data like the version of the remark, so it's usually 1.0. Then the name of the collection, then max, it means like how many NFTs are in the collection. So when it's like 1, 2, 3 or whatever, and if it's zero, it's like infinite. And then we have like issuer, is like who created the collection. Then symbol is like basic ticker, like you can have Kusama or dot, whatever you want. Like you can have also the custom symbol like Dan or Ricky. Then you have ID, which is basically the first couple of bytes from your address and then appended symbol. Then you have the metadata, which is the link to the IPFS. Current owner is like when you transfer the collection from you to someone else. Then you have the NFTs, which is basically the array of the NFT entity, which we will look in later. Then you have something called event. So when event happens on the collection, we just store it. And then there are a couple of data like block number or meta, which is the IPFS metadata. Also, we have like the uh, last field called created at. So when the collection is created, we store it there. And if you spot, there is sometimes the exclamation mark and sometimes not. It means if the data is are required. So for example, the created at can't be null, but on the other hand, for example, the meta could be null. So it's either the ID of the metadata or it's null. And also for these NFTs, this array is not required. However, any data in the array is required. There is sometimes like other entity called NFT, and is basically the same as the collection with a couple of differences. So we have like one-to-many relation for collection. So we have collection entity, and each NFT have to belong in some collection. So then it's required. We also have something called hash. So if someone is gonna make like the poster or banner for the profile, it's using like the MD5 hash from the string, not index. It creates another like table in the Postgres, which allows us to query the hashes faster. And then we have also the metadata owner, also price, which is required. And in before in the subquery, it wasn't required, so sometimes it was null, and it was, for example, for some queries really hard to write a good query. So now it's required. Then we have burned, also the same principle. You have to have true or false. You can have null, so it's either burned or not. And then there is block number, also the events we sometimes use, for example, for the landing page. Then emotes, also meta, created at and updated at. So now let's go to make some queries. And first we'll write a simple query using the subquery. I sent you the link to the coordination, I think. Yeah, it's in the coordination. So open the graphqlbin.com. I open it too. And use the second link, which is like coded.api.subquery.network. And yeah, so how to write the query? Our task is using subquery fetch the first my first collection with three NFTs inside, and from collection I want the ID and name, and for the NFTs I want ID, name, current owner, and the price. So how does the query look like? Oh, hope it's visible. And yeah, we start with a basic keyword called query, and then the rule of thumb I use is like I write it as a function. So I want my first collection. So my first collection, and then from it I want the collection entities. You see the difference? There is collection entity, which tells like I want one, but it requires the parameter of ID. And there is collection entity, which entities which tell us that I want array of some collections. So I use now collection entities. And what I have inside the collection entities, I can go right on this like schema or docs. Yeah, docs. And I see that collection entities takes a lot of parameters, but also they have couple of types. So they have some nodes, they have some edges, page info, total count, and some aggregations. So what I want is currently get the collection entity array. So I need to write the nodes, and then from the nodes I want ID and name. So ID, oh sorry, ID and name. Yeah, exactly. So I have from collection entities, I have like nodes, ID, name. And then I want some NFTs, which also requires us to have ID, name, current owner, or price. So also we have to write nodes, ID, current owner, price, and name. So this is our first query, but it's still missing something. And what does it missing is that we need like my first collection. So how to parameterize this query? It's simple. When you have the query and the name of it, you make these brackets, and then inside it you can specify the parameters you want. So I want something which is called account. In GraphQL, it has prefix with the dollar, and then you have to specify the type. If you usually the type is also in the docs, but for this, it's of type string, and it's required, so I have to use the exclamation mark. And now I can write the filter. Basically, if you use in the Postgres, like where, so here is something called filter, and it takes the brackets, and now we can write like what we want. So we want that it's my collection, so the field it's called issuer, and the issuer should be equal to my address, so equal to, and this account. And when can I get the account? If you look down here on the query variables, I have something defined which is called account, which exactly match this parameter with $account, and it has a parameter of my address. So I have this, and it requires me to just query the first one. So I write something like called first and one. It's the same as a limit in the Postgres. So we have my first collection entity, which is my. And then from the NFTs, you can also query like the first three, I think was the case. Yeah, with first three NFTs. So I write also here first three, and that's it. I call it, and ta-da! I have my first collection with a couple of NFTs which has these parameters I want. The good thing about GraphQL is like you instead of REST, you don't overfetch the data, so you still trying to make the query like you take query only what you need, so you don't fetch more data. So yeah, this was simple, and now I give you like one hands-on for yourself. And also here are the links of GraphQL, bin.com, and also the API. And try this for yourself. So using subquery, fetch my first five collection and just one NFT. So it would be really, really, really same as the first one. So it shouldn't take you a lot of time. So yeah, go for it. Let's give it 5 minutes, or just yeah, say when you're ready. So open the GraphQL bin, and then this address. It's in the coordination channel. Okay. So what's your solution? Or not ready yet?
Just a second.
Yeah. Okay, so ready?
Yeah, I finished my query.
Okay, perfect. So what have you done?
I think the base structure is same with the last one you implemented. Only we changed the first parameter and some like a field name based on the demand.
Yeah, perfect. So yeah, I think this was the solution. So you change the first instead of one you had five, and then the filter was basically the same, and then the NFTs was instead of something else that he was the first one, and also a couple of more data. So yeah, let's make some harder tasks. And yeah, the current task is using also the subquery, fetch my first five NFTs where the given account is issuer but not the current owner. So it means that yeah, you have to make the filter quite a different, but yeah, still you have to use this parameter account. So I give you also a couple like 5 minutes, and yeah, let's try it by yourself. And yeah, one more thing, instead of collection entities, you have to use here the NFT entities, and then the filter.
Does anyone else have issues with the user interface of GraphQL bin? Like I cannot open the NFT entity filter.
You have to use NFT entities.
Yeah, sure, but I wanted to check what filters there are. And when I open like the type in the third column of the graphical user interface, it always closes instantly.
Like
Like
this,
sorry, can you show again?
the docs and the schema.
Yeah, and when in the second column, if I want to see another type, it just closes the third column for me.
Okay.
Oh, for you it stays open. Damn.
But although I can give you a hint, all of the types are string, so both the issuer and both the current owner are strings.
Oh, okay. Okay.
Okay, ooh, so how is it going?
I'm ready.
Oh, perfect. So what was your solution?
I'm pretty much like the other request we had before, but in the filters, we also need to say current owner not equal to, and then the account, I guess.
Yeah,
And first 5. Then in the
yeah,
notes, just ID, name, current owner, and issuer.
yeah. So I guess this was the similar
Yes,
query you had.
right.
So issuer equal to account and current owner not equal to account, and then all this stuff. So yeah, perfect. We managed that, and yeah, let's get to the another part of this tutorial. And now we, instead of subquery, we use subscript, which is a bit modern than subquery and also with a lot of data. So let's check the playground first. It's like app.gc.subscript beta rubic 004. The link is in the coordinations. So if you see, there's a difference between the subquery and subscript. First, subscript comes with the display ground out of the box, and it's super cool because you can like don't need to write the queries by yourself, but you can use the explorer on the right side, and there are it's mostly the same, but there is one exception. So when you were using the notes for example for the collection entities, you have to also write the notes. But in here in the subscript, we don't need to use that. We just query it directly. So when you use collection entities, you just fetch what you want. So example ID and name, and that's it. And there is like a couple of differences between the subquery and subscript. First is that we don't have any like first keyword. Instead, we have a limit, which does basically the same. So we can use the limit, I don't know, 5 or yeah, let's say 5. It's fine. And instead of filter, we have where here. So and where is like written differently than the filter in the subquery, and these things are directly right off the box. So if we want to have the same example that where the second one, sorry, where the issuer is equal to account, we can use it simple. So the issuer is equal to some account, and we need that current owner is not equal. So it's like current owner underscore not underscore eq, and here we also use the account, and it's basically the same as the previous one. So now we use account here, and see it's simple and out of the box. And I need to copy my address, and yeah, here on the down you have query variables, and it's basically the same JSON account and my address. I can query it. Ooh, okay, I broke something. Ah, okay, should use the NFT entities. Sorry, this is the same. Yeah. So see, it's like super simple, and there are like few changes. But what I really like, for example, on subscript, we can use the more advanced examples. So one of these is like we can based on the, for example, for collection entities, we can query if, for example, you have some NFTs or not. So you can use other data. So let's see. Hope it's big enough. And we can use the filters. For example, if some NFTs, that NFT sum, and we can use another filter. So from the collection, for example, take only this collection. If some of the NFTs, for example, has the current owner like this, So we use now account. So this query basically means that give me these collection entities where in some of the NFTs have the current owner equal to this account. I said, so let's take ID or a name, for example. Ooh, it's a big query, so it's good to use the limit. And you see, I have like ton of the filters, like ton of the collections, and as you can see, not all these collections are mine. These are, for example, case profile banners or Japandas. So I have some pandas and so on. And if you also query the issuer, you see that these are mine and these are not. So it's really super cool to query all the other stuff. So let's try this example. And using subsquid, fetch the first two collection that has some non-burned NFTs and fetch these two non-burned NFTs. So for collection, I want just ID and name, and for NFTs, just get the name. So also I give you 5 minutes, and the address is in the coordination. And maybe one small point here, we are using the subscript in version 4, and we on the production we are using the version 5. There's the difference in between the, for example, caching of Spotlight and Cirrus Insight. But for learning, it's really nice to just use this old one. And also the version 5 is using the newer engine, but it's like less stable. So we are using both versions right now. So let's try this query, and we also give each other like 5 minutes or 10.
Vicky, do you mind to like paste your account to the coordination room so that I can test with my query?
Yeah, sure. I'll give you
Yeah,
mine.
thanks.
If you don't have any NFTs,
Yeah,
uh,
I haven't got one.
okay.
Mm,
So this is my
okay,
address. You
okay,
can use it.
thank you. Mm.
No problem. Okay, so how is it going?
I'm ready.
Perfect. And Junwei?
Uh, I haven't yet. For the first two, I was.
And wanna finish your or
Yeah. I can watch your. I don't want delay, so you can take over.
and how did you start it? This
Hmm?
start. How did you start it with the query, or where did you stuck?
I was looking for like first two collections and the fetch two. I mean the is that for the limit?
Yeah, for yeah, first is actually the limit. There are like this
Oh,
the small difference. So yeah,
oh, I
instead of
see.
first, you just write the limit.
Oh, yeah. Okay, then I finished.
Okay,
Uh,
perfect.
okay.
So
Thanks.
wanna tell us the solution, or Kilian can tell?
Oh, so collection entities where NFT sum weren't not equal true, I guess, and then
Yeah,
limit 2, and then in there NFTs limit 2 where weren't not equal true, or do I even have to write that? The filter.
yeah,
Okay,
yeah,
and in there just name, and for the collection also ID and name. I like that. Sorry.
yeah. Okay,
Oh, it's
I
burnt equal false, right? Oh,
oh
Yeah,
yeah,
it's numbered.
numbered. Yeah, but you can use also non-equal true,
Oh
but
yeah, not equal.
but
Yeah,
but it's easier to read like burnt equal false than burnt not equal true,
sure.
because you can write like burnt underscore not underscore equal true is the same, but this is like more performant and also
Okay.
like easier to read. Yeah, good. And yeah, I had a last last example which is like bit harder, and there are like two more entities I haven't told you about, or just we skip it. And when you open the subquery, subscript, we have couple more entities. One of these is metadata entity and event. And what I mean is like you can query from the NFT entities, let's say limit one, just for the test purposes. We have the event, which are basically, if you been on Codedot, is the like history table. So it has the interaction. It's still, here are the docs where are all the entities can list. And event has basically four fields. First is like ID, which we need to have, then the timestamp, then the interaction, and then the color and meta. So what it means, ID is something just generated because you save it as an entity into the database, so we need ID. Timestamp when it was when it was created, then interaction, like if it was list, if it was buy, if it was mint, or this was like consume, or let's say burn. Then the caller, like who called that action, and the meta. So if you have, for example, the list, the meta contains the parameter like how much money it was listed. So if we query the first NFT entity, and also there, let's do it. Oh, what I really like about GraphQL is like it's really super strict on you. So if you don't use any variable, it just tells you that no, please don't. So as you see, this NFT entity I just queried, it has only mint NFT, but using the filters, you can specify like you want just the NFT entity or NFT entities which has, for example, at least one buy. And the second field is like called meta, and it contains the data, the basic data from the metadata JSON. So it's like also ID, it's like image, name, animation URL, and also the description. So you see, like, I can query it. So ID is basically the same as the when you query the metadata. It's the same. Like if you see the metadata is the same as the meta ID, so it's the same for the like simple joining. Then we have the image, name, animation URL. If it would be something else other than the image, it would have the IPFS link here, then some description, and that's the stuff. And our task right now is like similar to the previous one. Is like using the subscript fetch first 5 NFTs that has at least one buy. So, you have to query the events, sum, and So let's give it also 5 to 10 minutes, and yeah, let's try to hack it. And then for NFTs, get these fields. For meta field, get the ID and the image. Oh, a typo here. And for the events, get just meta and the color. So give you also a couple of minutes, and let's hack it. Okay, cool. So how is it going?
I was still trying and stuck on that has at least one buy. I was looking for the field for the query field.
Oh,
Is that
so okay.
yeah?
I'll give you a hint. It's like event sum and yeah, interaction is should be equal to the by event.
Oh, I see. I will try that. Mhm.
Okay, so ready to present the solution?
I think you pretty much gave it away
Oh
already.
yeah. Okay, so what have you wrote?
Oh well, NFT entities, limit 5, where event sum interaction equal by.
Yeah.
And then I get the properties, ID, name, metadata, burnt. Yeah, right.
Yeah. Okay. And
Oh,
also
I didn't filter the events.
okay,
Interesting.
yeah. Yeah. Maybe I forgot it too. Yeah, okay. Perfect. So we passed that, and yeah, it was really nice
Uh,
to yeah, go
Maybe
on.
can I got a question? Is that we have to fetch the my first file? So for the NFT entities, should we put where issuer equal to like my account?
Uh, uh oh, my first. Oh, okay. Okay, so if you would do the my first, you should yeah pass or let's make it. If you would like to make like my first, let's close this. You would yeah do the same. Make a variable called account. It's like my preference. There is like you can call it however you want. I just use it like if it's ID, I just used ID. If it's like whatever else, I give it a name. And if you would like my first, then yeah, account where event sum, and then you need the if it's the current owner equal this account. Yeah, and we have the same. So if you, for example, query now the current owner, you see it's me. And also there is maybe difference between the issuer and the current owner, and the issuer like is who created the NFT, and the current owner is like who currently owns it. So there was not specified, but yeah, usually when you say my, I would be like, yeah, use the current owner, unless it's specified like created by myself. Or
Oh, see.
so if you have decoded it, and yeah, let's connect my wallet. Profile. So here is the collected. So collected means that the current owner equals my account. So you see it's from the other people, but still it's the current owner is me. If I would be have something like created, then I would expect that, oh, okay, created is it's created by me, so the issuer would be equal to my account, and current owner could be whoever else. So yeah, that's it. So yeah, happy to that you passed that. And yeah, links to know. There is a repo for Magic. It's under my account, but yeah, it will be migrated onto the under the coded. And there is already Rubik. And then if you would like to hack away more and get some bounties for it, I have already like a list of the queries which you could hack, and there are like a lot of things to hack upon. For example, really nice is the passion feed. So it's like you have to query the passion feed is basically the people you already collected from, and you only want to see gallery of people you already collected something. So first you have to filter the NFTs which you own. So current owner is you and you are not the issuer. Then fetch only the issuer, then filter only the issuers, and then make a big query for the gallery where you pass where that issuer is in the list. So let's give an example, would be maybe more related. So first query, we need the NFT entities, or let's clear this. So we need the NFT entities where the current owner is me and the issuer is not equal me account. So that's the first list, and I need only the, let's say, ID is, I think, the important part, because sometimes the Apollo is just really bad on you that it just fails if you don't provide ID. I don't know why yet, but I really found out that you have to query ID anytime. Still, you don't need it, and then get the issuer. So now you filter the issuers, like to make a set, so make a list unique, and then from these, basically we haven't showed the pagination, and I think if you hacked with pagination before, so basically how pagination works is that you do a limit and you do an offset. So for example 10, and offset is like 0 for now. So on the coded, if you have a list, so for example on Explorer and Gallery, here is the, as you have seen down below, here's the pagination, and how the pagination works is like we have like 3 times 4, so we have 12 images, and then you offset these images by 1 by the multiplication of 12. So how does the pagination works is like we have a limit 12 and offset 0, and we can get ID, and we can get the name, for example. Oh, account is not provided because we don't need it. And you see we can also, all these are all super old NFTs, so we can order it by block number descending. It's just basically said that from newest to oldest. We see that it's bit better. We can order it by created at descending would be best, and you see it's the same. And then when we want to go to the next page, if we basically have to skip this like first 12, so offset is 12, and we have second page. There are some mutants, there are some bots. And when we go to the like third page, we need to add another 12 to it, to the offset. So that's how the pagination works. And yeah, and when you back to the passion feed, if you get the list of the collectors, you also create where and the issuer in, and issuer in requires you to provide the array of strings. So basically you provide here the accounts. So it's dollar accounts where it's array. You just write these square brackets and then string, which is required, and then you just press here accounts. So that's the passion feed basically. And then you basically filter all the NFTs only by your like passion. So yeah, happy to see you to hack away more with the subquery and subsquid. And yeah, next session I would like to have for the like coded education would be setting up the indexer. So I talked previously about the Rubik. What will be in the next session, we'll go through the Rubik, how is it implemented, and then we'll talk a bit about the resolver, so the custom queries you can write on the top of the SQL directly. So yeah, happy that you joined, and do you have questions?
Yes, when you sometimes you say in some issues that we should write the resolver. What does that actually mean?
Oh yeah, okay. So resolver is what I would like to cover it in the next session, because this one was pretty packed with the new information, I think. And the resolver is here in the, you can make it bigger for sure. And you go to source, server extension, resolvers, and for example, the collection chart. Okay, maybe Spotlight would be better. So the resolver basically is the function you can call. It takes the arguments, same as the limit, offset, order by, order direction, and you basically write the raw SQL query, and then you call it on the top of the database itself. So you don't need to make any magic.
Okay.
But like the disadvantage of writing the resolver right now is like write the resolver with also a lot of the stuff, have the database ready, then test it, and then deploy it again. But thankfully, if you write the resolver, it just takes the process of testing and so on and so on, and we don't need to reindex the database. When we change the schema, like this schema.graphql, which is here, so if we change the one of the entities, we have to reindex the whole database. So it means we have to reindex the whole, I don't know,
Wow. Okay.
9 million blocks. So it takes time.
2
But
days.
if you, if you change just the resolver, it just needs to be tested if it works properly, and then it could be deployed. And it could be the whole process can be done in like 2 hours. So when in the issues are the resolvers, I would happy to follow up with the next session to learn how how to write these resolvers, but so far, yeah, just ping me and we can come up with something.
All right. Maybe a bit too advanced for me for now.
Yeah, I didn't want it to like pack it into the one session because it's really nice to just getting started with GraphQL to try the queries and build something on top of that, and that yeah move to the something more advanced, which are for example the resolvers, and then we maybe find out that the resolvers are not enough and that we have to come up with another solution. So for example, as I mentioned, in the difference between the 004 version of the subscript and the 005, which is like on the same address except the 4 is like 5 here, it looks the same except the spotlight table and series are now entities instead of the resolvers. And what it means, like we can fetch it much faster and we cache it like every I think hour or so, and it's much faster to be like to just read from the database and not to be dependent on some querying and so.
These queries on the left side, they are all
These are
defined in the by you, right? And not
yeah, exactly.
okay.
Or maybe by the resolvers, but yeah, but basically by me.
But yeah, okay. So it's not like I don't know, everybody uses these naming conventions, right? In other
No.
indexers, or I don't know what to call it.
Yeah, understand. Like no, it's like my convention to call it by like entity, and yeah, it comes from the time I wrote the magic, and I try to be as like agnostic as much as I can. So any indexer I'm building, I'm just maybe adding the features and not like changing the schema a lot. So for example, for the snack, it will have the same the collection entities, NFT entities, events, interactions, and all the same exactly the same stuff. So you can reuse the queries
Mm-hmm.
without need to write a lot of new queries. And if you and also we are building something called the coda.api or codapi, like if you merge the coda and api, and it's basically the query builder. So it's like more of the sneak peek that basically instead of writing these GraphQL events by yourself, there's like a functional wrapper that you just say like I want NFT by ID, and you just pass the ID, and on the background the app will build the query itself.
Okay.
Yeah, so happy to have you around. And any more questions?
Thanks for your sharing, Vicky.
Yeah,
Yes.
and also if you need the slides, I'll just fix some typos I found during the session, and yeah, I can put it online on my repo. Still, it's like the markdown, so you can set up anytime and go through the queries if you need it.
Okay.
Can you post it in the coordination?
Yeah,
A link to the repo?
yeah.
Yeah, cool.
Okay, perfect. So yeah, I was so happy to have you here and you learned something hands on. I think it was far better to just instead of checking the slides, you just go through the queries by yourself.
Looking forward next session.
Same.
Perfect. Okay, so I wish you like to have a really nice Thursday and enjoy the rest.
Thanks. You too.
Thanks.
Thanks.
Bye.
Okay, bye. So Dan, co nam powiesz?